This is a quick balancing review recording. I wanted to start here just as a reminder that maybe not through this recording, but when you get to the quizzes or homeworks in the course, you may see states of matter in the reaction. So in this generic reaction here, we have S, that's for solid, L for liquid, G for gas, AQ for aqueous, and those are not involved in the balancing. So all those are is to tell you what state of matter the elements or compounds are that you're using in the reaction. So you don't want to get confused with having to do anything with that stuff. All right, so I'm going to start here. These reactions here may not be real reactions, but using them just as a way to share what to do. And so when we're balancing, we have to add numbers in front, coefficients, because if we change subscripts, we change the compound. Right? So I need to balance this top one. I have 1 sulfur on one side. We don't write ones in chemistry, so there's just nothing there. We assume it to be 1. And on the right side, we have 8. And so the law of conservation of matter says that what goes into a reaction has to come out, the mass of the reactants equals the mass of the products. And so this can't happen. If 8 sulfurs come out, then 8 sulfurs have to go in. In order to fix that, I can't do this. So I can't add any subscripts because, again, that changes what the compound is. So I can't do that. But what I could do instead is put a coefficient in front. And so that's what we're doing to balance. We want to make sure whatever goes into the reaction comes out of the reaction. 8 sulfurs went in, 8 sulfurs came out, we're good to go. The second one down, we have 2 chlorines that went in and only 1 came out of the reaction. And so again, it doesn't work like this. It's not balanced. It doesn't follow the law of conservation of mass. And so I need to fix it. And again, I can't put a little 2 here, because if I do, that changes the entire compound. So instead, I have to put coefficients in front. So the way we balance is to put coefficients or numbers in front of each of the substances that is in the reaction. Right, let's look at something a little bit more complex. So here's our reaction. We're creating sodium chloride, which is table salt. And it looks like we have 1 sodium that went into the reaction, 2 chlorines go into the reaction. And now on the other side, only 1 sodium comes out, which is okay. 1 sodium went in, 1 came out. But now there's only 1 chlorine, and there's 2 over here. So again, what we cannot do is just put a 2 here, because that's not even possible. And so what I wrote down here on the periodic table, I included it just as a reminder about charges and how compounds form. Sodium is in group 1, it has a +1 charge. And chlorine's in group 7, it has a -1 charge. And so when they crisscross, the compound is sodium chlorine. So 1 sodium and 1 chlorine. Sodium has 1 electron, valence electron to get rid of, and chlorine can only take 1. And so if we were to put a 2 here, that implies that chlorine's taking 2 electrons from sodium, and that's not possible. So we can't change the subscripts. They have to stay the way they are. What we could do instead is put numbers in front. So I'm going to put a 2 in front over here to fix chlorine. So now I have 2 chlorines that went in and 2 that came out. So this 2 in front gets multiplied by whatever subscripts are there, and in this case they're 1s since they're not shown. So 2 times 1 chlorine is 2. So 2 chlorines went in, 2 chlorines came out. Now we have to go back though, because we changed sodium. 1 sodium went in and now 2 came out, because putting a coefficient in front of the compound applies to the entire compound. And so now I have to go back and put a 2 in front over here. And as your final step, you should always just double check the entire reaction. So 2 sodiums went into the reaction, 2 sodiums came out, 2 chlorines went into the reaction, and 2 chlorines came out, so balanced. Let's look at another one. So in these moving forward, I have the steps to balance down at the bottom. These are just suggestions. Once you balance a bunch and you get comfortable with it, you can, put these steps on in different order or do whatever you feel comfortable. But to start out, I would suggest going from left to right in the chemical reaction. Coefficients, remember, have to be whole numbers. We don't write ones. We assume them to be there. In combustion reactions especially, save oxygen for last. It's just a strategy. You can balance polyatomic ions as a group. Again, just a strategy, so optional. And like I said on the last slide, always go back and double check the entire reaction, because as you're balancing, you may fix one element and mess up another. So in this case, I'm going to go left to right. I have 2 hydrogens that went into the reaction and 2 hydrogens that came out. I have 2 oxygens that went into the reaction and only 1 oxygen came out. So I have to fix oxygen. I can't change the subscripts, but I could put a coefficient in front, in this case 2. So now I have 2 oxygens that went into the reaction, and 2 times 1 is 2 oxygens that came out of the reaction. So I've fixed that, but in doing so, change the hydrogen. So now I have 2 times 2, 4 hydrogens that came out of the reaction. So I need to get now 4 over here. And you want to ask yourself, 2 times what gives me 4? 2 times 2 gives me 4. And now it should work. But as your last step, always go back and check. So we have 2 times 2, 4 hydrogens that went into the reaction. 2 times 2, 4 hydrogens that came out. We have 2 oxygens that went into the reaction, and 2 times 1, 2 oxygens that came out of the reaction, and so therefore works. All right. Here's one more. In this case, we have in our steps to solve that you should save oxygen for last. It's a good strategy to do. However, if you see that you have oxygen in your reaction and one is a 2 and one is a 3, you probably have to get to 6 there, right? The only way you're going to make them equal is to get to 6, as far as, I guess, lowest coefficient that you could use, or most reduced coefficients you could use. So if you see that, you could start right there. But in a lot of other reactions, especially in combustion ones, now this is considered combustion, but not typical combustion with the hydrocarbon. But when you see hydrocarbon ones, which I'll share with you in a few moments, you probably want to save oxygen for last. In this case, I see right away that I'm going to need to get to 6, so I'm going to start there. So I'm going to put a 3 in front of this oxygen. 3 times 2 is now 6 oxygens that went into the reaction. And I'm going to put a 2 here. 2 times 3, 6 oxygens came out, so I've fixed the oxygen. Now I have 1 aluminum that went into the reaction, and 2 times 2, 4 aluminums that came out. So I ask myself, 1 times what gives me 4? 1 times 4 gives me 4. So 4 aluminums went in, 2 times 2, 4 aluminums came out, 3 times 2, 6 oxygens went in, and 2 times 3, 6 oxygens came out. Let me take a look at the next few slides I have here. This one's similar. I'm going to skip over this one. I'm going to pause on this one. So maybe if you'd like to pause the recording here, you could give this a try, and then I'll share the answer. Okay, first I'm going to add a plus sign in here that seems to be missing. All right, so in this case, right now I have 1 aluminum went into the reaction and 1 came out, so that's okay. I have 1 hydrogen that went into the reaction and 2 came out. And so I'm going to start by putting a 2 in front over here, which I'm going to have to fix. But let's let that go. And now I have 2 chlorines that went into the reaction and 3 that came out. So I need to fix that. I have 2 on one side, I have 3 on the other. Again, probably need to get to 6. So I'm going to back up, get rid of that 2, and I'm going to start with chlorine this time and get to 6. So if I put a 6 in front here, now I have 6 chlorines that went into the reaction. And if I put a 2 here, I have 2 times 3, 6 chlorines that came out. So it's really just trial and error. I went from left to right, but saw when I got to chlorine that I had an odd number on one side, right? I had 3 on one side and 2 on the other at that point. And so you can use that idea of getting to 6 and then start over. Right, so I'm going to go back to the beginning then. I have 1 aluminum that came in and 2 that came out, so I need to fix that one. 6 hydrogens went in and only 2 came out, so I need to fix this one. 3 times 2 is now 6. And again, we have 6 chlorines that came in and 2 times 3, 6 that came out. Okay. So this slide here, the next 2 slides actually are ones that we did in class for practice. So you could pause the recording here and give these a try if you'd like. Here's the answers. And then we also did these 3 in class as well. You could pause the recording here if you'd like to give these a try. And here's the answers. And so up through this point, this would be considered basic balancing. So straightforward reactions, we didn't have to do anything crazy there in order to balance these. So the next half here would be more complex balancing. First up, we talked about balancing polyatomic ions. This is an optional strategy. If you don't want to do this, you don't have to. You can continue doing what we just did. But to share an example with you, if you see you have polyatomic ions, which I do here right away, I see nitrates in parentheses. If you're able to pick it out, sulfate is also a polyatomic ion. And so I have 2 choices. I'm going to look at nitrate first. So I could say I have 2 whole nitrates because there's a 2 on the outside of the parenthesis. So I can balance that as one big group, a nitrate. I have 2 of them. Or I could say I have 2 times 1, 2 nitrogens, and 2 times 3, 6 oxygens. Right? So remember, when you have subscripts outside of the parentheses, you have to multiply in order to identify how many you have. But it may be easier to just balance that as a polyatomic ion, and it may save you some time. But again, it's optional. It's just a strategy. Because I have a polyatomic ion here, I'm just going to go right there. And I'm going to take a look. Right now I have 2 whole nitrates on this side. And I have 2 whole nitrates on the other side. So that's okay. I have 1 whole sulfate on this side. Again, there's no parentheses and number on the outside, so assume it to be 1. I have 1 sulfate on the right side. I have 1 iron on the left, 1 iron on the right, and 1 barium on the left, 1 barium on the right. So this reaction is actually already balanced. It saved us a little bit of time that we looked at the polyatomic ions as a group. And so there's nothing I have to do here. It's already balanced. And when you get to the homework or the quiz, the more challenging balancing quiz, there is one of the reactions that's already balanced. So you want to look out for that. All right, let's look at another one. So in this case, again, I see a polyatomic ion, I see nitrate. So I'm going to go there first and see if that saves me some time. So I have 1 whole nitrate on the left, and I have 3 nitrates on the right. So I'm going to start by putting a 3 in front over here, and now I've balanced the nitrogen and oxygen all in one step really quickly. And so again, it's an optional strategy, but if you balance the polyatomic ions as a group, it may help. Now I'm just going to go left to right. So I have 3 silvers that went into the reaction. I should put a 3 here then to get 3 to come out. I already did the nitrate. 3 nitrates went in, 3 nitrates came out. 1 iron went in, 1 iron came out, and 3 chlorines went in, 3 chlorines came out. It's balanced. This next one here, you could pause the recording and try to do the polyatomic ion strategy. Okay, I'm going to go ahead and balance. This time I see sulfate, SO4, it's a polyatomic ion. I'm going to start there, may save me some time. I have one sulfate on the left and I have 3 sulfates on the right. So I'm going to start by putting a 3 here. I'm going to go back then and start at the beginning. So I have 1 aluminum that went in and 2 came out. So I need a 2. I already did the sulfates. Let's look at the hydrogen. I have 3 times 2, 6 hydrogens that went in, and 3 times 2, 6 hydrogens that came out. And again, 3 sulfates went in and 3 sulfates came out, and therefore bound. All right, 2 more kind of groups. So this is just a reminder that oxygen is sort of, say, a popular element and may appear in more than one compound in a reaction. So you want to look out for that. It oftentimes happens with combustion reactions because we need oxygen gas in order to make combustion happen. And we always end up with the same products of water and carbon dioxide, both containing oxygen on the product side. So whenever we start with the hydrocarbon, we always end up with water and carbon dioxide in a combustion reaction. And so now we have oxygen appearing in 2 places on one side of the reaction. So we just have to be careful. It's just look out for that to happen. I'm going to save oxygen for last in these types of reactions as well. You'll see that it'll come in handy here in a moment. So I have 1 carbon that went into the reaction and 1 came out. 4 hydrogens went into the reaction and only 2 came out. So I'm going to put a 2 here. 2 times 2 is 4. And now I'm going to look at the oxygen. I have 2 oxygens on the left, and I have 2 times 1, 2 oxygens in water. And I also have 2 oxygens in carbon dioxide. And so when you have the same element in 2 different compounds on the same side of the reaction, you just have to add them together. So I have a total of 4 oxygens on the right side and only 2 on the left. So I need to put a 2 in front over here to balance that. So again, you just want to be careful when something like that happens. So to go back to the beginning, one moment. To the beginning, I have 1 carbon went in, 1 carbon came out. 4 hydrogens went in, 2 times 2, 4 hydrogens came out. 2 times 2, 4 oxygens went in. I have 2 oxygens here, plus 2 more over here, so 4 came out. That one's balanced. You'd like to pause the recording and give this one a try, you can. In this case, we have chlorine in multiple compounds on one side of the reaction. Okay. So I have 1 hydrogen that went into the reaction and 2 came out. So I'm going to put a 2 here. I have 2 chlorines now that went into the reaction, but I have 2 over here plus 2 more here. So now I have a total of 4 chlorines that went into the reaction. So I'm going to back up already and change this number. So I'm going to change that to a 4. So now I have 4 chlorines that went in and 4 came out. 4 hydrogens that went in and only 2 came out. So I'm going to put a 2 in front over here to balance that. I have 1 manganese went in and 1 manganese came out. 2 oxygens went in and 2 times 1, 2 oxygens came out. Great. One more like this. So again, if you'd like to try, you could pause the recording and give it a try. All right, so in this case, we have a few things happening. We have oxygen in 2 places on both sides of the reaction, and we have a polyatomic ion. So I'm going to start with the polyatomic ion, and it may help me to balance quicker and deal with that oxygen in multiple places. So I have 3 whole sulfates on the right. So I'm going to put a 3 in front over here and say I have 3 whole sulfates on the left. I'm going to go to hydrogen again. And again, you could go from left to right. But the more you do these, the more you may say, oh, okay, I'm going to start here with the polyatomic ion. Now I see hydrogens getting to 6, so I'm going to do that on the other side and then check that other oxygen. So 3 times 2, 6 hydrogens went in. I'm going to put a 3 in front over here, so 6 hydrogens came out. I have 2 irons that went in, 2 irons that came out. And now I want to make sure I double check the oxygen that is not in sulfate, right? We already balanced sulfate as a group, but we have another oxygen over here. So we have 3 oxygens that went in and 3 times 1, 3 oxygens that came out. So this one's balanced. So again, this one you had some options, whatever you'd like to do. All right, one last skill, and that is fraction balancing. And so this comes in handy to save you a lot of time, especially when you're working with combustion reactions. Our final balanced reaction has to have whole numbers, but we could use fractions to get there, and it will save us a lot of time. You don't have to, but it will take you a while to go back and forth in a lot of cases in order to get your final answer. So I'm going to use fraction balancing with these combustion reactions and save oxygen for last. So the reason why we do that is because oxygen's sitting here by itself, and we can then easily balance it when it's sitting alone and put whatever we want in front of it without changing the other elements. So that's why we want to save oxygen for last. Again, on the right-hand side, we have oxygen in 2 places in these combustion reactions, so you want to be careful. All right, so we have 2 carbons that went in and only 1 came out, so I'm going to put a 2 here. I have 6 hydrogens that went in and only 2 came out, so I'm going to put a 3 here. And now we're down to oxygen. Right? So on the left side, we have 2. On the right side, we have 3 here. 3 times 1 is 3, plus we have 4 in carbon dioxide. 2 times 2 is 4. So we have a total of 7, which is an odd number, and there's nothing that we can multiply to get 7 as a whole number for our coefficients by 2. Maybe I should back that up. 2 times a whole number is not going to get me to 7. And so I could keep going back and forth until I figure this out, or I could use fractions. To use a fraction, you take the number you need, so I need 7 oxygens, and you put it over whatever the subscript is next to the element you're trying to balance. In most cases, it will be a 2. Sometimes you may find a 3, but I'm going to put that over 2. And now it's balanced, but we can't leave it this way because our coefficients have to be whole numbers. So we have to go back through and get rid of that fraction. To get rid of that fraction, I need to multiply by 2, right? 7 over 2 times 2 is 7. So if I multiply this by 2, I just get 7, so that's good. But just like in algebra, if I multiply one substance by 2, then I have to multiply everything by 2. So I have to go back to the beginning of the reaction and say 2 times 1 is 2, 2 times 3 is 6, and 2 times 2 is 4. And now it's balanced. So to double check, we have 4 carbons that went in, and we have 4 carbons that came out. We have 2 times 6, 12 hydrogens that went in, 6 times 2, 12 hydrogens that came out. We have 7 times 2, 14 oxygens that went in. We have 6 oxygens here, plus 8 more, so 14 that came out. Let me do one more. So again, I'm going to save, I see a combustion reaction with a hydrocarbon, so I'm going to save oxygen for last. I'm going to start with carbon. I have 4 carbons that went into the reaction, so I'm going to need a 4 here. I have 10 hydrogens that went into the reaction, so I need a 5 here. 5 times 2 is 10. And now I see another odd number. We're probably going to end up with an odd number of oxygens. We have 2 that went in. We have 5 over here in water. Plus, we have 4 times 2, 8 in carbon dioxide. And so that's a total of 13. which is relatively a bigger number. And so if you don't use fractions, it may take you a while to go back and forth to figure out how you're going to get a 13 on the left-hand side. So I'm going to use the fraction shortcut basically to help me out. I need 13 oxygen, so I'm going to use that number. And I'm going to put it over whatever the subscript is, and that is 2. Now the reaction's balanced, but I can't leave it this way, so I need to get rid of that fraction. To do that, I can multiply it by 2, and then I have to multiply everything else by 2. And that's it. Now everything's balanced. Okay. Here's one for you to try. You could pause the recording here and give it a try. Okay. So 6 carbons went in, 6 came out now. I put a 6 in front. 14 hydrogens went in, 7 times 2, 14 hydrogens came out. I have 7 oxygens here plus 12 more. So that is 19 oxygens on the right-hand side and only 2 on the left. So I'm going to use a fraction to help me out since that's an odd number. I need 19, and I'm going to put it over the subscript, in this case 2. But then I have to go back and get rid of the fraction. So multiply everything by 2 again. And you're done. Okay. This last slide here were 2 that we had done in class together. It gives you the fraction balancing as well as the polyatomic ion balancing. So you could pause here and try this one if you choose. All right, so on the top, I have 2 carbons went in, 2 came out now. 6 hydrogens went in, 3 times 2, 6 came out. I have 3 oxygens plus 4 more, so again, I have 7 on the right. I'm going to put a 7 over 2 to fix that, and then multiply through by 2 to get rid of the fraction. I think we did this one a few slides ago or something really similar. So now that's balanced. In the one down below, I am going to balance phosphate as a polyatomic ion. So I have 1 phosphate over here and 2 on the right, so I'm going to put a 2 in front. Now I'm going to go to hydrogen next. Technically, hydroxide is a polyatomic ion, and although I didn't mention this in class, oftentimes when you get to acid-base reactions, instead of writing H2O, you write HOH. Just to show the acid and base side, hydrogens signify acids and OH, hydroxides, signify bases. And so if you had written this like that, you could see the hydroxide matchup. But we haven't gotten there yet, so I'm not going to do it that way. I balanced the phosphates. I'm going to go to hydrogen next. 2 times 3 is 6, so I'm going to put a 3 over here. 1 calcium went in, 3 came out, so I need to put a 3 in front here. And now I have again, you could look at this as 3 hydroxides here, and 3 times 2, 6 over here, but we're not going to go there with this particular one. So I'm going to say I have 3 times 1 times 2, basically. So I have 6 oxygens here and only 3 over here. And I have 3 times 2, 6 hydrogens on the left. And again, I have 6 here, but I also had 6 more over here, so a total of 12. So I'm going to change this number in front over here to a 6. And so now I have 3 times 2, 6 hydrogens here, and 3 times 2, 6 hydrogens here, so that's 12. 6 times 2 is 12. I have 3 times 2, 6 oxygens here and 6 oxygens here, so that works. I didn't count the phosphate oxygen because I already balanced that with the phosphate. And so this one actually is a little tricky since we didn't talk about hydroxide, so you're probably not going to, well, at least talk about hydroxide in water, so probably not going to pick that out. But it just goes to show that balancing it as polyatomic ions is not necessary. It's a strategy. So you could have done this all separately as well. And that is it. So I'm going to go ahead and open up that balancing homework. If you'd like to get together, just let me know.